So PicnicHealth, at PicnicHealth, we set out from the beginning to solve a problem, to solve what feels like a pretty basic problem. We wanted to basically look at these great United States of America that we have, and we wanted to just be able to take like any one person, any random person, no matter who they are, anywhere in the country, and be able to get all of their medical record data. So let's just say you're a random guy. We'll call you Steve. So you're Steve, and you come to me and you say like, hey, can I get my medical records? Can I get my medical data? And I look at you and I basically say, well, a few people have tried this before. By the way, I don't have authorization for any of the pictures in here. So there's a few folks have tried this before, right? Trying to put the patient at the center of their own data. So we know that we're not going to be able to beat them, trying to do the same thing that everyone else has struggled so much to try to do. So we said, let's do something a little different. And I'm going to tell you why we took some lessons from the Wizard of Oz in building PicnicHealth. So step one for Steve here is like, okay, we have to get your records. We just have to get them. And so what we built was pretty simple. We just built some basic interfaces where you could come and just tell us your basic information, sign a form really easily, like review and authorization, and just sign a form saying, you can request my records, and then just tell us who your doctors are. That easy, right? So we've got this great interface, and then, the question is like, what happens when you peer behind that curtain, right? Like, who's actually back there? What's going on behind this really nice interface? And in Silicon Valley, or at least in some circles, people call this type of thing Wizard of Ozing. So when we started the company, it was Sophie that was behind the curtain, actually. So, we literally had, and this is not a model, this is actually who was doing the work. Sophie came to us. She had worked at an amazing women's clinic in the Mission in San Francisco and had a lot of experience requesting records for patients. Essentially, what she was doing was, we sort of set out and said, like, in order to be able to do this, right, to take this one guy and get his records, we have to deal with the existing infrastructure of the healthcare system. And basically, in healthcare, like, information exchange mostly, like, not everywhere, but it's like all PDFs getting e-faxed around, right? It's like people making requests and PDFs getting sent around the system. So we knew we had to work with that. So, at the beginning, it was just Sophie. And then we built this thing internally. This is the first time I'm showing this. My team doesn't know I'm showing this. We built this thing called Hodor. And what Hodor does is it allows someone like Sophie to basically, the very first time, like let's say Steve tells us that he has a doctor at Scripps. I don't know if that's even possible, but he allows us to, so it allows us, like, the very first time to kind of go in and say, okay, we see this fax number online that we can use to send this record request. We send a fax, nothing comes back. We make a phone call, and basically what they tell us is, oh, well, you have to put attention Mary, and if you're calling the cardiology clinic, you have to put it in 14-point font and send it to this other fax. And so we actually built this drag and drop tool so Sophie could just map these things, right, in a really systematic way. And Sophie only has to map this thing once. And then the next time we make this record request, we can basically click a button or just automate it, and fax goes out and fax comes back in, hopefully, unless something changes. And so we now have 10,000 different provider facilities in Hodor. And so we've gone from, the wizard having to do lots of things in the background to the wizard having to do less and less things in the background. this is what our system looks like. So this is like everything that can happen, and we just have sort of slowly automated pieces of it. I realize you guys can't read this, it's mostly funny. So you, right, like you can, someone can come, you know, the office can come back and say, oh, we don't have those records, or this signature doesn't look right, or there's an invoice to pay, or, you know, we don't have a patient by this name, and then an email can get sent out automatically that says, oh, you know, Stanford has no record of you. Were you under a different name? Were you at the Menlo Clinic? So, you know, you start learning these things and basically slowly construct this system that takes makes things more magical and less Wizard of Ozing going on. Okay, so now we got all your records. Great. We've nailed getting medical records. So now we have to turn them into data. Again, here's the interface, right? So, you know, this is what PicnicHealth actually looks like to patients. It's very like streamlined and sleek, very consumery. So, you know, again, here we're gonna go behind the curtain. Let's see what's going on. Well, at the beginning, it was Jillian behind the curtain. And Jillian's a physician. And we built a whole, I mean, at the very beginning, it was Jillian just typing data into Excel, but we basically built a whole platform to make it really easy for Jillian and, you know, eventually nurses and other folks, you know, like her to be able to basically look at a medical record and like really easily go through and structure the data from that record. So the tool, you know, they can sort of just kind of click through and what you're seeing here, which I'll get into in a second, is that over time, you're able to actually start predicting what's in the record and predicting how the data will be structured. So we have, you know, an algorithm that will go through and kind of guess what's in the record, and then Jillian or someone like her essentially, you know, uses these tools that make it really easy to just kind of correct and say, I mean, one thing might be like, oh, that's an 83, not an 82. Or it might be like, well, that vitamin D test, you know, that has X loink code should actually have Y loink code because it's a blood and not a urine. So we basically built these tools to make data structuring a lot easier. And we use a system to automate things. So again, at the beginning, this was very, very manual. We've now labeled using, you know, the tool that you just saw. We've now labeled 500,000 records. And so we use the system that people call human-in-the-loop computing. So essentially, you have machines, right? So at the beginning, like, I'm sure there'll be talk about AI today, right? You can't go to a healthcare, maybe there already has been, but you can't go to a healthcare conference and not hear a lot of talk about AI, especially this one, probably. So you can't create AI, like artificial intelligence, without having training data. So at the beginning, we were just labeling these records basically, you know, in this very manual, arduous, expensive way to just create training data, to just give like essentially an algorithm something to create a model from that would, you know, sort of like, you know, paper goes in and what comes out on the other side is structured data. And we now are at the point where we have enough training data that the algorithm can do a decent job of guessing what's in the record. And then as it turns out, the best way to train an algorithm is to feed it back the corrected results of what it got wrong, right? Because you're sort of telling it the things it doesn't know how to do. And so as the nurses on our team are going through and saying, oh, that's the wrong loink code for that lab test, they're actually also creating more training data and the most effective type of training data to feed back into the algorithm to improve the automation over time. So this is essentially the human-in-the-loop learning system that both produces really high-quality data for patients directly and is also over time getting trained to, you know, do a better and better job of not needing the humans behind the scene. So we've been able to drive, there's nothing on the bar here, but there's no actual cost here, but we've been able to drive our cost down tremendously, right? So at the beginning, we had this very like concierge-y, expensive service, and we were losing money on every customer, and the costs have gone, down really, really dramatically just by getting a lot of this automation working. And I'm just going to preview that we'll have some exciting stuff happening in a few weeks. We're going to be able to start passing some of those savings through to hopefully get more patients able to sign up directly. So, all right, now we've got data. We've got all this structured data. Why do we care, right? Like, what can we actually do when you have like one person, right? Like, we're not talking about, I think I was talking to the gentleman from IBM yesterday was saying, I think they had like 700,000, or I want to say like 500,000 patient records. Like, there's massive data sets out there. So the question is like, why do we care if we have like, why do we care if like Steve has his data, right? If there's like one person and you can actually get their stuff. And the reason is because there's things you want to do with that person's data, right? Not just with kind of like big data sets you can get out there, but like we want to actually take your care and put it on a timeline so you can see, what's happened over time and what's going on. Because we structured the data, you can do things like say, okay, these lab tests that you've had done at the 8 different universities you've worked at, in 8 different states, like you can take those labs and put them all in the same graph and actually see like how are things going over time, instead of just getting like one snapshot at a time, and not having that cohesive view. And then we can surface things, right? So I'm sure there are physicians in the room. Everyone, I think, who's looked at a medical record knows that there's a lot of what's in there is just like, okay, I clicked the button that said I did a review of systems, and then the like review of systems appears in the medical record. So we kind of take that junk out. Like, it's there, you can always click through and look at it, but we basically will just surface the like, okay, here's the thing the doctor actually wrote about what happened in this visit, for example. And that's, an important thing to be able to do. Of course, you then want to be able to take your records and move them around between all your different doctors. You may have family members that are caregivers that you have like your child that's wants to be involved in helping you with your care that lives on the East Coast, or you have like a sick child and there's a mom and a dad who are, both looking at records. So being able to send and actually share your information is incredibly powerful. Maybe you're going into a doctor's visit and your doctor says like, okay, well, we need an MRI of this, we need a thoracic MRI. And so instead of saying, well, I don't have my MRI, and the doctor says like, well, okay, we'll just do another one, they can actually pull up, it's a shame I can't demo this here, but like this is actually an FDA approved DICOM viewer where you can really make a diagnosis right in the browser, with the, and essentially as a patient, you're carrying this around and you can give your doctor access to it. So those are some of the like things you can do as a patient, right? Like as an individual, you now have control of your data for your own care. But the other thing you can do is have control of your data so that you can actually agree to give it to other people, to feed it to other apps and other tools. And in particular, I'm going to talk about a few places where we work with researchers where it ends up being incredibly valuable to be able to share this data. So we have an API that we've built where third party, obviously with our permission and with patient permission, can actually pull out an individual's data. We use the OMOP standard, so everything is set up to be really, as like a basic schema, to be really easy to do analysis. So we, here's just one example. We work with NORD and the Undiagnosed Disease Network, and this is a case where you have kids mostly kids who just, it's just, they basically have medical mysteries, right? Like no one can figure out what's going on with them. And this clinic has been set up. There's 7 clinics around the country for physicians who are really skilled at this type of work to be able to, really thoroughly look at all of the patient's history and, try to figure out what's going on. This ends up being really important for research as well, because when you have these rare cases, you're often able to discover new, make genomic discoveries, or just discover like novel phenotypes for like a particular condition. So this is the kind of case where it's just like incredibly important to have all of the patient's data in one place. That's one example. We have done a project with the Myotonic Dystrophy Foundation. So myotonic dystrophy is a rare, it's a rare form of muscular dystrophy. And this is a condition where like nobody even knows, there's some activity, potentially drugs, potential compounds to test, and nobody even really knows what this disease looks like, right? Like there's no good literature just on what is the natural history of this disease. Like at what age do, there's like some basic information, but at what age do people start showing symptoms? When do they, what does the progression look like? Just some very basic things that you can't even like plan a clinical trial or just benchmark how a patient's doing if you don't have this basic information. So you used to have to do like a very arduous kind of like traditional registry to get this data, where you would sort of go to all these hospitals and, basically say, go to all these health centers and centers of excellence and say, I'm sure there's people here who have run these registries, and say like, hey, if you happen to see a patient with myotonic dystrophy that meets this criteria, please like type the data into our system. And, in 5 to 7 years, maybe we'll have a set of data where we can do natural history. Well, we basically go directly to the patient, go get all their records, and we work with some of the scientists that are involved with with MDF to say like, what are the interesting endpoints and how can we make sure we're abstracting, not just labs and medications, but also like looking at the narrative text and pulling out like the important symptoms that you want to know about. And so we create a very customized, very complete, thorough data set that allows for a natural history study. And then the last one I'm going to mention, which can't go without mentioning, is the All of Us research program. Some of you may have heard of, which we're so excited to be involved with. And so this is another kind of typical use case for us in the sense that it's not typical in the sense that All of Us is creating a 1 million patient cohort. But one of the things that the All of Us study is doing is essentially, trying to bring together phenotypic and genotypic data. And for folks in this audience, I'm sure but just to kind of give my non-medical explanation for what this actually means, if you have genetic data, it turns out it's super helpful if you know what happened to the people. And you can actually match, that person's genetic data with those outcomes. And those outcomes basically live in their medical records. You may be able to ask them like a few things and get some basic information, but if you actually want to know if you actually want to know in a lot of detail and just sort of be able to look for associations that maybe you weren't expecting, having the medical record data there is incredibly important. And so this is just, I think, like another reason why, really kind of important case for why it's super important to keep making these like big data sets, which are incredible, and we have like incredible discoveries coming from them. But there's really no substitute for also at the same time making sure that like one person, one set of data, one row or row on a set of tables that represents that person, where like if they have a spit kit, it can be matched up with that data. It'll take a long time to get to 350 to 500 million. If we're only in the U.S., 350 million people, but But even at smaller numbers, when you have this very high fidelity data, you can start doing really interesting things. So this is just to give a little bit of hope. I guess we have our own yellow brick road. We're not going to Oz. This is Americana, but I think like we are slowly, you know, with lots of crazy things happening behind the scenes, starting to make some progress towards unifying patient data and, you know, creating our own version of interoperability. And I just want to say a quick thank you to these guys who helped me find a charger when I couldn't get my presentation off my computer. Thank you.